For this lecture, we will be covering the first half of section 1.4, which is all about quadratic equations. Right? So first off, what is a quadratic equation? Let A, B, and C be real numbers where A does not equal 0. So therefore, a quadratic equation, or a second degree equation in the variable x, is an equation which can be written in the form ax squared plus bx plus c, which is equal to 0. Right? So this may look familiar. So big emphasis, we do not want A has to be a non-zero number. Why? Because if A is equal to 0 for ax squared plus bx plus c is equal to 0, when that is, we get bx plus c is equal to 0. And what is this? This is a linear equation. Bless you. Right? So A cannot equal 0. So now, let's talk about this theorem. A theorem is called the zero product property. You may have recalled I mentioned this last week. And it says that if m times n is equal to 0, then m is equal to 0 or n is equal to 0. Because remember, 0 times anything is equal to 0. Right? So if m is equal to 0, so for m times n, if m is equal to 0, then we'll get 0 times n, that's 0. And if n is equal to 0, we'll get m times 0, and that is also equal to 0. Right? So this is a very, very powerful theorem that we use quite often. Right? So let's do some examples. Right, so the first example, I'm given y plus 6 times the quantity y minus 2 is equal to 0. Right? Actually, before we do this example, I do also want to say, so it says that the quadratic equation in the variable x, right? So it's ax squared plus bx. So if we have a quadratic equation in the variable of y, what is that? That would just be ay squared plus by plus c is equal to 0. Right? Same thing goes for like t, okay? At squared plus bt plus c is equal to 0. Right? Where they're just variables. Right? So, let's continue on with our example. Alright. So, we have this. In this case, right, we're just going to use the zero product property. Okay, so question for you is like, why aren't we going to FOIL this? Because if we FOIL this, we get y squared plus 4y minus 12. Right, this puts us in a worse situation than what we were before. Right, so we're going to use the zero product property, right, because this is multiplied. So I'm going to say y plus 6 is equal to 0 or y minus 2 is equal to 0. Right? So if we do that, we get y is equal to negative 6 or y is equal to 2. Right? And to check your answer, you can just plug these values in. If I plug in y is equal to negative 6, I'm left with 0 times negative 8, which is 0. That's good. And if y is equal to 2, so this was y equals negative 6. If y is equal to 2, right, then we get positive 8 times 0, and that is 0. Right, so our solution is negative 6 and 2. Right. Our next example, we are given x squared minus 8x is equal to 0. Right? And we want to solve for the variable. But as you can see here, we have the variable x in two of our terms. So what can we do? I noticed, so because of that, since they both have an x in common, I'm going to factor that x out. And what will I get? I will get x minus 8 to 0. Right, when I recheck this, I get x squared minus 8x, so this is equivalent, so this is good. And now we can use the zero product property because this is multiplied in the middle, right here. Right, so I'm going to say x is equal to 0 or x minus 8 is equal to 0. Right, so we get x is equal to 0 or x is equal to 8. Right, you plug them in. You can plug it into this one, or this one. It doesn't matter because they're both equivalent. Right, the only way you can use it on the second one though is if you double checked your work and you got the same thing as above. Right, that's what we did, so we're good. So if we plug in 0, we get 0 times negative 8, that's 0. And then if we let x equal 8, we get 8 times 0, which is 0. So, okay, this is it. Or you can write x equal to 0, 8. Or you can write this in the solution set. That's our answer. Right. Now let's look at example 3. Example 3, we are given 2x times the quantity x minus 7, and this is equal to negative 12. Okay? So before, like for example 1, we could just use the zero product property, but the biggest thing there is it has to equal 0. Right? Is negative 12 0? No. So we have to do some moving around before we start solving for x. So what can we do? If you want, we can add 12 to both sides, so we'll get 2x, x minus 7, and this plus 12 is equal to 0, right? But we still can't use the zero product property because this is addition, right? So what we're going to have to do is we have to distribute this 2x, right? And see if we can refactor anything. Right? I notice there's a 2 in common, and so I'm going to say x squared minus 7x plus 6. This is equal to 0. Right? If I divide 2 from both sides, I'm left with x squared minus 7x plus 6 is equal to, and then 0 divided by 2, that is 0. One thing I wanted to point out, if you notice that there's a 2 here and the 12, you could have also divided 2 from both sides first, right? Like I said, it doesn't really matter what, it matters the order, but just, you can do, like there's multiple things you can do first, right? But you just have to make sure your logic makes sense. Like you could have distributed first before you added. Right, just make sure your logic makes sense. Right, now we're gonna factor. So I factored the other day, but I didn't really go into it. So let me do a little review. Right, I'm gonna talk about the AC method. Right, and that's the only method I'm gonna talk about. If you know the guess and check method, that's good. Like you can go ahead and use that. But I think the AC method is easier to explain. Right, so the AC method, what does that mean? So when you use the AC method, you're considering ax squared plus bx plus c is equal to 0, right? And you're going to ask yourself, what two numbers multiply to be a and c, and then add to be b? Right, so I usually make a chart. Okay, and what are we doing? We're doing a times c, which is 1 times 6. Right, so we're asking ourselves what two numbers multiply to be 6 and add to be 3. Right, so let's start listing them out. You can do 1 and 6, but when you add those, and okay, and then we, let me rewrite this. we're going to multiply to be 6, and we want it to add to negative 7. Right? What that also tells me, so since this is negative, when you have a positive over here, okay, what two numbers can give you positive numbers? It's going to be positive times a positive and a negative times a negative. Right? So since there's a negative in the middle, that means that both the numbers we're looking at have to be negative. Right? Right, so when we multiply this, we get positive 6, and when we add them, we do get negative 7. Right, so that actually is over, but you could also have checked negative 2, negative 3, right, and then you would have seen that didn't work because it adds to be negative 5. The moment you get the correct one, you don't have to keep going. So this is kind of like you don't have to write that other option. I just want to show you guys there was another one, but it wouldn't work. So what is this going to tell us? This tells us it's going to be x minus x squared minus x minus 6x plus 6 is equal to 0. Right, and then we do this factor by grouping. So what are we going to do? We're going to group these, right, and be very careful here. Since there's a negative, we have to make sure we're adding, okay, because negative 6x plus 6, this is not the same as saying negative and then 6x plus 6. Right? Because when we distribute this, what do we get? We get negative 6x minus 6. Right? And these two, they are not the same. Right? When we do that, we have an x in common. This is x minus 1. Okay? I want this x to be positive, so I'm going to factor out a negative 6. Right? And that'll get me x minus 1. Okay? These two terms, there's an x minus 1 in common, so I'm going to factor that out. And when I do that, I'm left with x minus 6. Right? So, and this is called factor by grouping, is when you have 4 terms. However, okay, what do you notice about these values, the negative 1 and negative 6? It's what we found. Right? So, if you wanted to, you could have gone straight from here. Right? But the biggest thing here, I really want to emphasize, the only time you can do this is like put the negative 1 and negative 6 in these places is if a is equal to 1. Right? If a is not equal to 1, you're going to have to do the factor by grouping. Right? So, now that we factored this, right, we're so close. Now what we're going to do is we're going to use the zero product property. So it's going to be x minus 1 is equal to 0 or x minus 6 is equal to 0. So then we get x is equal to 1 or x is equal to 6. Right? And when I plug these in, okay, to check our answer, I'm going to plug it into this one right here. All right, so if x is equal to 1, what do we get? I'm going to do a different color. We get 2. And then we get negative 6. Does this equal to negative 12? Guess what? Yes, it does. Okay, so that value works. And then now let's check x is equal to 6. When we do that, we get 12. And then we get 6 minus 7, which is negative 1. Does this equal to negative 12? Yes, it does. Okay, so what does that tell us? That tells us that our solution is x is equal to 1 or 6, right? Or you can write it in the solution set like that, right? Whoops, oh my goodness. Okay, now let's talk about the fourth example. The fourth example, I'm given x squared is equal to k. So just an arbitrary number k, and we're solving for x. Right, so what am I going to do? I first want to set this equal to 0. So I'm going to subtract k from both sides. So I have x squared minus k is equal to 0. Right? If I do the AC method, Okay, actually, you could, I don't want to do it, but recall the difference of squares. Okay, what is it? It is, I'm just going to say a plus b times a minus b is equal to a squared minus b squared. Right? Before you ask, how come this is not plus, multiply this out, you're going to get this exactly. The reason why it's not plus is because we're not dealing with complex numbers. This is the difference of squares for real numbers. Alright? So we have this, so we're only given two terms. We're given this x squared and this k, and then there's a minus in the middle. So that tells me I can make this as a difference of squares. So in this case, we know that x squared is equal to a squared. So what does that mean? That means x is a. And then if I have a k, so we have b squared is equal to k. So what squared gives me a k? It's going to be square root of k. Right? So I'm going to rewrite this. So I have x plus the square root of k, x minus the square root of k. Okay, and if you FOIL this out, we're going to get x squared minus k. Right? And if I use the zero product property, I would get x plus square root of k is equal to 0, or x minus square root of k is equal to 0. When I solve for this, I get x is equal to negative square root of k, or x is equal to positive square root of k. Right? So, as a solution set, this will be, I'm just going to put plus or minus square root of k. Right? And this brings me to the next theorem. Right? The theorem is the square root property, and it states if x squared is equal to k, then x is equal to plus or minus the square root of k. Right? And the solution set is written as k negative k or plus or minus k. Right? So this is also a very powerful tool. So let's do some examples. Oops. Right, so the first example, we're given x squared is equal to 49. Right, keep in mind it says if x squared is equal to k, so there's only one term. Well, I guess k could be anything, but the main thing is on the where there's the variable, there's only one term, and and the coefficient is 1. Alright? So over here, the coefficient is 1, so we can go ahead and use the square root property. So what is this? This is x is equal to plus or minus the square root of 49. In this case, what is the square root of 49? It is 7, because 7 squared is equal to 49. Right? And if I plug this in, positive 7 quantity squared is 49, and negative 7 quantity squared is 49, because negative 7 times negative 7 is positive 49. Right, so what does that mean? That means our solution set is plus or minus 7. Right? What about the second one? The second one, I have 2x squared plus 50 is equal to 0. Right? So I have two terms on the left side, right? That's a no-no. So let's move over that 50. So let's subtract 50 from both sides, and when we do that, we get 2x squared is equal to negative 50. Right? When we do the square root property, we want the coefficient to be 1. The reason why is because when you take the square root of 1, it's 1. Right? So that's why we can apply it. So now let's divide both sides by 2, If I do that, I get x squared is equal to negative 25. Right, now I can apply the square root property. So I have x is equal to plus or minus the square root of negative 25. Right, let's simplify this more. Okay, what is the square root of negative 25? It is plus or minus 5i. Okay, what I didn't do is, so the square root of negative 25, this is I square root of 25. Alright, I just didn't show that. Alright, but remember 5 squared is 25. Right, even if I did 5i quantity squared, this is going to be negative 25 because this is 5 squared I squared. So 25 times negative 1, which is negative 25. All right, let me get more space. Right. So our solution set is plus or minus 5i. Okay, you can check it because we already established x squared. So 5i quantity squared is negative 25. Negative 25 times 2 is negative 50. Negative 50 plus 50 is 0. Right? Last problem. Right? We have w minus 2 quantity squared is equal to 8. Right? So since this whole thing is squared, right? So this, we'll treat it as our x. Okay, so let's still use the square root property. So when I do this, I get w minus 2 is equal to plus or minus square root of 8. Right? And so some of you might be confused right now. You might be saying, well, I thought you said it's supposed to be one term. Technically, this is, like, I understand, like, this whole thing is just one term. Right? I know it gets kind of confusing because the w and negative 2 can be considered them as well. But what I'm saying is on the left side, if you want to use the square root property, like whatever is in the parentheses has to be squared. It can't be this plus like 2x or something, right? Or like have a 3 right here. It just has to be a big O thing that's squared. And then we can apply the property. So let's continue. So I want to get w by itself, so I'm going to add 2 to both sides. Then I will get 2 plus or minus the square root of 8. Okay. Before we're done, okay, I need to see if I can simplify the 8, and we can. It is 2 plus or minus 8 can be rewritten as 4 times 2. So this is 2 plus or minus square root of 4 times the square root of 2, and this is 2 plus or minus 2 square root of 2. Right, you can factor out the 2 if you want. Not really worth it. Okay, so let's write 2 plus or minus 2 square root of 2. And this is our solution. Right. So for the remaining of this time, I'm going to do 4 more examples. Right, and then we'll do these in-class problems on Monday. So let's go ahead and get started. Okay, we're going to practice our factoring because factoring is really important. It's something I still do today in my classes. All right, so let's do x squared plus 3x minus 28 is equal to 0. Right? So we want to solve for x, but this is a quadratic. Since it's a quadratic, we have to factor. So what two numbers multiply to be 1 and negative 28? So what two numbers multiply to be negative 28 and add to be positive 3? Right, if we make a table, okay, let's find multiples of 28. So if I start 1 and 28, okay, before I continue, we want to look at our signs. All right, so I have a positive here and a negative here. So what is this telling me? When I have a negative right here, it's telling, so, okay, technically not right there, but because it's positive. So since it's multiplying to be a negative 28, what does that tell me? That tells me my numbers have to be a positive and a negative. It has to be a positive times a negative. Right? So what does this positive 3 tell me? This positive 3 tells me that my bigger number is going to be positive. Right? So I'm going to make this one a negative. Right? So let's check it. This does multiply to negative 28, but this adds to be 27. So this is a no-go. Okay? What about negative 2 and 14? Okay? When I add, they do multiply to be negative 28, but they add to be 12. So this is also a no. Okay? 3 doesn't go in 28 perfectly, but what about 4 and 7? Right? It multiplies to be 28, right? And if I add them, they do add to be positive 3. So this is, these are the numbers we are looking for. Okay? Some of you might be asking, what if we don't know this whole, like what if we know it, the signs have to be different because we're multiplying to be a negative, but we don't know what sign to make positive? That's perfectly fine, because if I even said negative 7 and 4, yeah, that's equals to negative 28, but it adds to be negative 3. The only difference is the sign. So you see it's the 3, but it's negative 23, negative 3, and you're like, so close. What are you going to do? You just switch the signs. So you would just make this positive 7 and negative 4. Right? So the biggest thing is if it's multiplied to be negative, you have to know you have to do a positive and a negative together. Right? This middle trick, what I explained, is just a little kind of just thinking even more ahead. Right? But it's fine to do it this way as well, as long as you get to the right answer, which is this one. Since a is equal to 1, what does this tell me? This tells me I can just write x minus 4, x plus 7. Right? Because a is equal to 1. Even if we FOIL this out very quickly, if I do x squared plus 7x minus 4x minus 28, this would be positive 3x. This is the exact same as above, so that tells me that we factored it correctly. I'm going to use the zero product property. So I have x minus 4 is equal to 0, or x plus 7, which is equal to 0. So therefore we get x is equal to 4, or x is equal to negative 7. Right? If we plug this in, so if you check that this does FOIL to the top, you can use it, but I know we all can make silly arithmetic mistakes, so maybe I would plug it into this one just to really be sure. I know you guys are all capable of plugging in numbers, so we're not going to do that. So I'm just going to write the solution, which is this. Right? And let's go on to number 2. So number 2, I have negative 7m minus 2 is equal to 5m squared. Right? Our first goal is to set this equal to 0. Right? We want to get all our terms to one side. But your question might be, how do I know which terms to move around? You guys might be wanting to bring this negative, like this 5m squared over, because that's just one term. However, one thing is the number attached to your variable. Okay? You want it to be positive. Right? You want it to be positive. So what am I going to do? I'm going to add the 7m and add the 2. And when I do that, I get 0 is equal to 5m squared plus 7m plus 2. Right? If you wanted to bring the negative 5m squared over, you would just have to make sure it's positive. So you have to factor out that negative 1, right? And then divide that over, divide it from both sides. But that's just, in my opinion, a little just more work than adding 2 terms over. Okay, so this one's a little different because a is not 1, but still the same nonetheless. Right? So the AC method, we want to find 2 numbers, okay, that multiply to be a positive 10. So So multiply, and we want it to add to positive 7. Okay, so if I think 1 and 10, okay, so this is positive, and this one's positive. I'm just going to pick two positive numbers. When I add it, I get 11. All right, so that won't work. Okay, what about 2 and 5? They do add to be 7. Right, so how are we going to write this 7m? We're going to rewrite this 7m as plus 2m plus 5m plus 2. Right, actually, you know what I want to do? I want to add 5m plus 2m. Right, it'll still work if you do 2m plus 5m. I'll show both ways. Right, it's always good for you guys to see things done in multiple ways, so you know, like, it's just not one set way. Right, as long as logic makes sense, it's fine. So let's solve this. So I'm going to do the factor by grouping. Okay, I don't have to put a plus sign here because there's already like a plus, so it doesn't, yeah, so it won't matter in this case. Right, so over here, the first two terms, I see that they both have 5m in common. When I do that, I get m plus 1. Right, if I distribute it back in, I get 5m squared plus 5m. Okay, and over here we have a 2 in common. We're left with m plus 1. Okay, if we distribute it, we'll also get 2m plus 1. Right, before I continue, so right here, I guess to check your work from here to here, right, we got to just check the middle terms. For 7m, okay, it can be broken up into 5m plus 2m. When I combine these, we get 7m. Same thing as up here. Up here. I had a negative x and a minus 6x. Right? If I add those together, I would have gotten a negative 7x. Right? So that's just a good way to check your work. Okay, let's continue. So I look at these two terms, and I notice I have an m plus 1 in common. So I'm going to factor out that m plus 1. And when I do that, I am left with 5m plus 2. Okay, so now I can use the zero product property. So I get m plus 1 is equal to 0, or 5m plus 2 is equal to 0. Okay, then we get m is equal to negative 1, or m is equal to negative 2 over 5. Right. Again, you are all capable of checking this yourself, so I'll leave that for you. But our answer is negative 1 and negative 2 over 5. Okay, so very quickly, if I went with my initial thing, okay, I'll do it in a different color. If I did 0 is equal to, also, you guys could have also put equals 0, like on the right-hand side. It doesn't matter. Okay, so I have 5m squared. If I said plus 2m plus 5m plus 2, right? This is still doable. I was like, it's still going to give you the same answer. Okay, but over here, if we still do the factor by grouping, we just have to be a little more careful. Okay, 5m squared plus 2m, what's in common? The thing that's in common is, the greatest, so it's called the GCF, the greatest common factor. In this case, it's just m. Okay, if I factor that out, I get 5m plus 2. If you check your work, you will get 5m squared plus 2m. Over here, we have 5m plus 2. The GCF in this case is just 1. Okay. So that's why you have to be more careful, because some people, they won't even put the 1. They'll just keep it here. And then some wonky stuff happens, and they end up messing up. Okay. But if I factor out that 5m plus 2, then I'll get m plus 1. Right? And then even if I distribute this back in, I do get this. Right? So as you can see, same thing. The only difference is that this and this, they're switched. But multiplication is commutative, so it doesn't change it. Alrighty, so just a couple more examples. Okay, so we have 9w squared is equal to 30w minus 25. Again, our goal, we want one side to equal to 0, right? So we were going to want to move some terms around. How do we know which terms to move around? We want to look at the a, right? We want to look at the coefficient of the highest. We want to look at the leading coefficient. In this case, it's positive 9. So that tells me I want to move these terms over, okay, to keep that 9 positive. So then I'm left with 9w squared minus 30w plus 25 is equal to 0. Right? I don't know about you guys, but finding two numbers that multiply to be 9 and 25 and add to be negative 30, that seems like a lot of work. So I want to show you guys some tricks. Right? So keep in mind, so the perfect square trinomial square, I'll just put it's trinomial. Remember, it is a plus or minus b quantity squared. This is a squared plus or minus 2ab plus b squared. Okay, so why do I bring this up? Because if you notice, this a, so a is 9, okay, and then maybe I shouldn't put a. Okay, sorry. I know having multiple, like the same variables, it gets kind of confusing. So let's say this. Let's say m plus or minus n. Right, it's m squared plus or minus 2mn plus n squared. Okay, so in this case, a is 9, right? B is negative 30, and C is 25. Right, if you look at A and C, if you notice that they are both perfect squares. 9 can be rewritten as 3 squared, and C can be rewritten as 5 squared. Okay, 25 is equal to 5 squared. So if I let my m equal 3 and my n equal 5, okay, let's check it. If I do 2 times 3 times 5, what do I get? I get 30. Okay, so since these match these criteria, what does this tell me? This tells me I can factor this as 3w, okay, so technically m was 9w squared, or no, 3w. Okay, minus 5. And how did I pick 5? The minus 5 is because I get minus 30, right? So I have to make this negative. Right? Even if we factor all of this back out, we will get 9w squared minus 30w plus 25. Okay, so if I use the zero product property, I'm left with 3w minus 5. Okay, this is plus or minus 0, but what is plus or minus 0? It's just 0. Okay, so we don't need to do that. Okay, so I get 3w is equal to 5, and then we get w is equal to 5 over 3. Right, and that is our solution. Okay, so yeah, I didn't do it for the first two, alright, but it's because I already knew. But for this one, when you look at all the factoring problems, what I would do first is I would check the first and, maybe I should underline a different one. I should underline this one and this one. Alright, and see if these are perfect squares. 9w squared, it is a perfect squared because it's 3w times 3w is 9w squared, and 5 squared is 25, right? So these both are perfect squares, and what you want to do is you want to multiply it by the 2ac, or yeah. Okay, and then you just want to see if it matches, and if it matches, we can just go straight to this one. Alrighty, we are almost done. Okay, we just have one more example to go through. And the last example is 16k squared minus 49 is equal to 0. Right? So this one I want to point out the difference of squares. Right? So that is a plus b times a minus b. This is equal to a squared minus b squared. Right? So one way to check this, so it has to have, so these two terms both have to be perfect squares. They are 4k times 4k is 16k squared, and 7 times 7 is 49. And we also need to make sure that there is a minus sign right there. So what does that mean? I can make this 4k minus 7 to 4k plus 7 equal to 0. Okay, so 4k minus 7 equal to 0, or 4k plus 7 is equal to 0. So when I solve this, I get k is equal to 7/4, or k is equal to negative 7/4. Again, I'll let you guys check it on your own, but you should get plus or minus square root of 7/4. Right? Before I end this, I did see something else that you can do. Right? So some of you may like this better if you don't recognize the difference of squares, but what you can do is you can still set this up like a square root property. So you can use a square root property. So if we add 49 to both sides, we get 16k squared is equal to 49. Okay, divide 16 from both sides, you'll get k squared is equal to 49 over 16. Okay, so we get k is equal to plus or minus the square root of 49 over 16. Okay, use that square root property that we have, like the square root of a over square root of b is equal to the square root of a over b, right? If we used it this way, you can also use it this way. So this is plus or minus the square root of 49 over square root of 16. So we get plus or minus 7/4. Okay. Either way, as you can see, whoops, we can get the same answer. Right? So that's it for today. Come to class with questions, and we'll do these on Monday. Right? Bye.